Hello, welcome to Study Guide Forum. Today we'll be talking about temperature and its measurements. We're going to be learning about how we can measure it, and then that means as we get that, I want to encourage you to watch to the end, and then so that we'll be able to, really enjoy what we have for you today. So I'm so happy to have you here. If you are coming for the first time, we encourage you to subscribe. So let's go ahead. Let's quickly go down to what we are talking for today. Now we're dealing with what temperature and its measurement, like I said before. Now, there's something about temperature. Most time, people mistake temperature and heat. Temperature and heat, they are not the same because temperature has to do with the degree of what hotness of or coldness of a substance of a body or substance, while heat is a form of energy. Heat is energy is a form of energy due to what change in temperature due to what change in temperature. Now, and temperature is quite different because it measures the average kinetic energy of what the body molecule of the body. That's the uh, average kinetic energy of the molecule of what a body or a substance. So here now you can see that they are not really the same. So now how do we measure this temperature? How do we measure the temperature? We have two basic methods of measuring temperature. For example, now if I'm feeling hot, if somebody is feeling hot, or maybe I'm feeling hot, somebody can just touch me and feel my body and then know that my body is that my temperature is high. That means when my temperature is high, it means that I have high temperature, or maybe when it's cold. This is the type we call what by what sense of what touch. That's one of the ways. Note that. But one thing about this using of sense of touch is that it's not very reliable. So we have another method. I say that sense of touch. The another method is what use of what thermometer. Thermometer. Now, use of thermometer is the most reliable one, very, very reliable in the sense that we can tell you exactly, give you an accurate temperature in question. Because when you're using your sense of touch, you find out that there are some temperature you cannot read exactly. Just like warm water and hot water might be a problem because the warm water, if you put your hand in the hot water and change it to warm water, it might seem as if the warm water is what cold, depending on the level, the number of the how long you stayed in the hot water. So that is why this other one is not very reliable. We'll talk about this when we deal with it. So we have different types of thermometer. Types of thermometer. We have different types of thermometer. Hmm? So one of the types of thermometer, number one, we have liquid, liquid in glass thermometer. We have liquid in glass what? Thermometer. I said liquid in glass thermometer. The next one we have is what? Gas thermometer. I said what? Gas thermometer. The first one is what? Liquid in glass thermometer. The second one is what? Gas thermometer. I want you to get this into your brain. So the next one we have here is the one we call resistance. Resistance thermometer. I said what? Resistance thermometer. That is the third one. I said the first one is liquid in glass thermometer. The second one is gas thermometer, and the next one is what? Resistance thermometer. The next one we have here is the what? The one we call thermocouple. Thermocouple thermometer. Thermocouple thermometer. I say thermocouple thermometer. The last one that we have is the one we call a bimetallic thermometer. Bimetallic thermometer. Now, all these thermometer they have what we call thermometric substance. This thermometric substance is the substance that they contain that help them to what do the work as what thermometer. Now, in this thermometer, they have different types of thermometric substance. For example, when we talk about the liquid in glass thermometer, the major thermometric substance they have there is what? Mercury. Mercury or what? Alcohol. Mercury or alcohol. I said this word, mercury or alcohol. You need to pay attention to this. Just remember, I said that it's what? Mercury or alcohol. Now, why is this one very good for this liquid in glass thermometer? Now, in this one, they have one physical property that we consider in using them in this. The physical property that we consider in using liquid or mercury in glass liquid in glass thermometer is the ability of the liquids to expand with what? Temperature. I say the ability of this liquid to what? Expand with what? With the temperature. As the temperature is increasing, the volume of the liquid will what? Increase. The volume will keep increasing. Now, for this other one, the gas thermometer. The gas thermometer, the thermometric substance we have here is gas. Now, the physical property that we use in ascertaining the best gas that we're going to use is what? The ability of gas to what? Expand. The volume, change in volume with what? Sorry, change in volume with what? Temperature, or change in what? Pressure with what? Temperature. That is, change in volume with temperature at constant pressure, or change in pressure with what? Temperature at constant volume. These are the two things that we normally consider in using this any of the gas for gas thermometer. And then we go back to the resistance thermometer. In resistance thermometer, the thermometric substance there is resistance wire. So the physical property we consider in this one is the change in electrical resistance of a wire with what? Temperature. I said the change in electrical resistance of a wire, resistance wire with what? Temperature. That is what we consider anytime we are trying to choose any of the resistance wire or wire that we're going to use for this. So the next one we have here is thermocouple thermometer. Here we use the similar metals, that is metals of different conducting ability. They are not the same. For example, iron and copper can be used because they are not the same. And iron and copper, their conductivity varies. So this is what we use here. And the physical properties that we use, I want you to know this one, is what? The change in the electric change in current, or change in electrical potential difference of these two of the two metals, two metal junction at different what? Temperature. So that is what we consider whenever we're using it for this. Now we talk about the bimetallic thermometer. Bimetallic thermometer also uses what? The similar metals. Uses what? The similar metals. In this case, in the bimetallic thermometer, in this case, what we do here, we consider the what? The same physical property we consider in this case is that ability of them to expansion of these different metals with what? Temperature. The expansion of different metals, because let's say it's a iron and maybe copper or any other substance, you find out that the expansivity rate varies with temperature. So that is what we consider in this case. So the next thing we'll talk about here is we're going to be talking about the fixed point. Each thermometer, note this thing, they have two fixed points. And if you're joining us for the first time, we want to encourage you to do what? Subscribe. And if you have any question, you can also leave it in the comment section there. We will always attend to you. And The next thing we are already said, we said going to talk about the fixed point of the thermometer. Thermometer has two fixed points. It has two fixed points. I said it has what? Two fixed points. The two fixed points include what? The upper fixed points and what? Lower fixed points. Now, this upper fixed point is the temperature of steam from pure water boiling at standard pressure. At standard pressure, that what we mean here is that standard pressure of what? You know that standard pressure is what? 760 millimeter mercury or 1 atmosphere. That is the temperature of the steam from pure water at that temperature. That is what we use in this case. Okay, they just took my light. Anyway, let's continue. I believe that this thing is still bright. You can still manage this light. So this thermometer, I said something about the upper fixed point. The upper fixed point is the temperature of the steam from what? Pure water boiling at standard standard pressure, not temperature, please. Standard what? Pressure. So this other one, the lower fixed point, is the temperature of melting pure ice at temperature as at standard pressure, at standard what? Pressure, at standard what? Pressure. That is also 760 millimeter mercury or 1 atmosphere. So in this case, the difference between the lower fixed point and the upper fixed point is what we call the what? The difference here is what we call the fundamental in interval. That's it, in fundamental interval. I say fundamental interval. The difference between the two in your thermometer displays the upper fixed point and lower fixed, what we call the fundamental interval. Another one we want to be looking at here is the scales. Thermometric scales. We talk about that. We have about 3 types of thermometric scale. The first one we have is the one we call the Celsius scale, and we have what? The next one is Kelvin scale, and finally we have Fahrenheit scale. Fahrenheit. And the Celsius, the Fahrenheit can also be called the absolute scale. Absolute scale. But the Fahrenheit is not very common. This is the commonest one is all about this. So that's what we have. Thank you so much for being part of this class. And in our next video that will be coming up after this is where we'll be doing some calculation on how to do some of the calculations that involve this very thing. I don't want you to miss that one. If you have come this far, I want to say thank you. Thank you for being part of the class. And now we start not minding the light that has just gone off. For you to be here, thank you so much. And don't forget to subscribe if you have not, and also share, and also like. And I want to hear from you. In fact, if you don't know what to tell me, then you can just tell me where you're watching me from. I'll be so happy to see that. I will reply you speedily. Thank you so much.